Welcome to the DIY Honda Garage channel. The DTC P050B is an error code that indicates a problem with the cold start ignition timing control system. This system plays a crucial role in determining the correct timing for ignition during colder engine starts, facilitating smoother and efficient engine operation. If the timing is off, it can lead to rough idling, poor fuel economy, and increased emissions. Vehicles experiencing this code often need a thorough diagnostic to identify contributing factors. Understanding the exact cause is important to ensure the longevity and performance of the vehicle. The subsequent troubleshooting steps will help pinpoint the issue and restore proper function. The DTC P050B relates specifically to a malfunction in the cold start ignition timing control system. This system is part of the PGM-FI, or Programmed Fuel Injection System, responsible for regulating the fuel supply and ignition timing to optimize engine performance, particularly during cold starts. The critical components affected are primarily located in the engine compartment, where the main electronic control unit operates along with various temperature sensors. Understanding the location and function of these components is vital for effective troubleshooting. Accurate reading of the engine coolant temperature is also essential to the control system's performance during cold starts. Identifying any faults in these areas assists in diagnosing the root cause of the issue effectively. There are several possible causes for DTC P050B, each linked to how the cold start ignition timing operates. First, the presence of any pending or confirmed DTCs can signal other underlying issues which might directly affect ignition timing. Blockages in the intake air duct can restrict airflow, impacting the air-fuel mixture, critical for effective ignition. Similarly, a malfunction in the air cleaner housing can lead to dirtier air supplies. Additionally, if the air cleaner element is dirty, it can cause further complications, creating an inconsistent air supply during ignition. Lastly, a faulty crankshaft position, CKP sensor, can lead to incorrect readings of engine position, directly affecting ignition timing. Understanding these causes is key in effectively diagnosing the error. The symptoms of DTC P050B manifest primarily during the initial start of the vehicle. One of the most noticeable indicators is a rough idle, which often occurs during cold starts due to miscalculated ignition timing. This roughness can lead to further engine performance issues, including noticeable decreases in power and responsiveness under acceleration. Additionally, fuel consumption tends to increase as the engine struggles to maintain efficiency, leading to greater emissions as well. Finally, the check engine light, CEL, is typically illuminated, alerting the driver to a malfunction that needs attention. Recognizing these symptoms can help guide timely diagnostics, preventing long-term engine damage. The first troubleshooting step for DTC P050B involves turning the ignition switch to on, position 2. This prepares the electronic systems for diagnosis. Using the HDS, or Honda Diagnostics system, check for any pending or confirmed DTCs present alongside P050B. It's vital to record all errors, as other DTCs can point to secondary issues influencing the cold start ignition problem. If any other DTCs are identified, the troubleshooting process will need to shift towards those specific codes instead. Should no additional errors appear, proceed to the next step. By methodically checking for additional DTCs, we ensure that all potential issues are resolved, leading to a comprehensive repair. In the second troubleshooting step for DTC P050B, the focus shifts to a visual check of the intake air duct. This component is essential for directing airflow into the engine, significantly affecting combustion and ignition timing. Inspect for any blockages or kinks that could inhibit airflow. Additionally, verify that all connections are secure to prevent air leaks that could disrupt the air-fuel mixture. If the intake air duct is found to be in proper condition and function, you can proceed to the next diagnostic step. These checks, though critical, are often overlooked, but can be the source of several engine performance issues. The third troubleshooting step requires a visual inspection of the air cleaner housing. This housing is responsible for filtering contaminants from the incoming air, essential for optimal engine performance. Any blockages or poor connections here can lead to an insufficient air supply, which ultimately disrupts the ignition timing needed during cold starts. Inspect for signs of damage or clogs within the housing. If any issues are detected, repair accordingly and then proceed to verify the repair. However, if the air cleaner housing proves to be functioning well, continue to step 4. This consistent inspection process ensures the integrity of vital components affecting engine combustion. In the fourth step, check the air cleaner element for any accumulation of dirt or debris. This element is crucial for filtering air entering the engine and directly affects the quality of combustion. If the air cleaner element is dirty, it should be replaced promptly to restore optimal airflow. A clean element will also support the exact calibration of ignition timing during cold starts. It's essential to perform this check regularly, as a clogged filter can severely hinder engine performance. If the air cleaner element is clean, proceed to step 5 for further evaluations. But if dirt is found, replacement is crucial for restoring engine efficiency. The fifth troubleshooting step involves verifying that the engine has cooled down to 122 degrees Fahrenheit, 50 degrees Celsius, or less before proceeding. This ensures that accurate and reliable testing conditions are met. Once cooled, use the HDS to clear the DTC P050B from the system. After clearing, start the engine and let it idle for a minimum of 10 seconds, observing the OBD status. This allows the system to reevaluate conditions and check for the persistence of the DTC. If the Honda Diagnostics system indicates a failed status for DTC P050B, that would imply that the issue persists and further investigation is necessary, highlighting the importance of this verification step in the overall diagnostics process. In step 6, focus on determining the ignition timing of the engine. This step is vital, as proper ignition timing is crucial for efficient engine performance and smooth operation, especially during cold starts. If the ignition timing is confirmed to be within specifications, you will proceed to step 8. However, if the timing is incorrect, it indicates a potential malfunction within the system that requires more detailed assessments. By ensuring that the ignition timing aligns with specifications, you mitigate risks of engine performance degradation or damage. This step also sets the foundation for subsequent troubleshooting steps and repairs directly tied to ignition function. The 7th troubleshooting step involves a thorough visual inspection of the CKP sensor, also known as the crankshaft position sensor, and the CKP pulse plate. These components are crucial for detecting the position of the crankshaft, which informs the ECU on when to ignite the fuel. Inspect these parts for any signs of physical damage or wear, as deterioration can lead to erroneous readings and consequently ignition timing issues. If any damage is found on either component, replacement is necessary to restore accurate sensor function. If both parts are in good condition, the next step involves checking the ECU for software updates or confirming the unit's functionality. This meticulous checking process serves to ensure that every linked component is assessed, laying the groundwork for successful repairs. In Step 8, performing the ETCS, or Electronic Throttle Control System, test using the HDS is crucial for checking the functional state of the throttle body. The throttle body controls the amount of air entering the engine, significantly affecting combustion efficiency and performance. During the test, observe the throttle actuator control valve for normal operation. This ensures that the valve opens and closes as required. If normal operation is confirmed, proceed to Step 9. However, if any issues arise during the test, it may indicate that the throttle body requires replacement. This step is vital for ensuring a consistent air supply during ignition, thereby preventing further issues in engine performance. The 9th troubleshooting step requires starting the engine and holding it at 3,000 RPM without load until the radiator fan activates, which is key in assessing the mass airflow sensor. During this process, maintain the engine speed at 2,500 RPM for 30 seconds, while simultaneously monitoring the MAF sensor readings with the HDS. The expected values should fall between 7.0 to 8.6 grams per second. If these values are observed, it indicates that the MAF sensor is functioning correctly. If the sensor does not fall within this specified range, it necessitates replacement. Proper MAF sensor operation is crucial for optimizing air-fuel ratios and ensuring effective combustion, making it a vital component in addressing DTC P050B. In the final troubleshooting step, check the values recorded by ECT sensors 1 and 2 against the ambient temperature. First, ensure the ignition is turned to lock and allow the engine to cool to ambient temperature. Once cool, switch the ignition back to on and log the values of both ECT sensors using the Honda Diagnostics system. If either sensor shows a temperature difference greater than 5.4 degrees Fahrenheit, 3 degrees Celsius from ambient, it indicates a malfunction, necessitating replacement of the faulty sensor. Conducting this test is essential, as improper sensor readings can substantially impact ignition timing and overall engine operation. If both sensors are functioning correctly, additional evaluations of the related components must be made, ensuring a comprehensive resolution of the DTC P050B issue. The final repair verification process involves a series of key steps to ensure that all previously identified faults have been addressed and rectified. Begin by turning the ignition switch to lock and reconnecting all connectors that were previously disconnected during diagnostics. Following this, utilize the HDS to reset the engine control module, ECM, a critical step in clearing any lingering fault codes. Next, execute the ECM idle learn procedure, which helps the system recalibrate itself for optimal performance. Allow the engine to cool to 122 degrees Fahrenheit, 50 degrees Celsius, or below before starting it again to observe the OBD status. If the reading indicates passed, then the troubleshooting process is complete. If failed, return to earlier steps for another inspection. Efficient verification is essential to ensuring long-term reliability of repairs. Preventive maintenance is critical for avoiding future occurrences of DTC P050B and ensuring the engine operates smoothly. Regular inspections of the air filter should be performed, as a clean air supply is essential for proper combustion. Monitoring the status and performance of all relevant sensors, including those in the ignition timing system, helps catch potential issues early. Additionally, keeping electrical connections clean and securely fastened can prevent issues related to poor signal transmission. Taking proactive steps in maintaining these components will lead to improved engine performance and prolong the life of the vehicle's essential systems. These practices contribute to enhanced reliability and efficiency over the long run. In conclusion, addressing DTC P050B requires a systematic approach anchored in effective troubleshooting and preventive maintenance. Recognizing the early symptoms, such as rough idling or decreased fuel efficiency, can facilitate quicker diagnostics and repairs. Particular attention must be paid to the function and performance of engine sensors, as they are integral to maintaining proper ignition timing. Regular inspections and maintenance practices are paramount for safeguarding against future emissions and engine performance issues. By following these steps in sports, vehicle owners can ensure their Honda Civics run smoothly, efficiently, and reliably for years to come. Please like and subscribe to the channel. See you next time.